Let's look at our second section for this week, which is 7.3. So we're going to be finding solutions to trig functions. As I said, we're going to focus on doing it graphically, but we still have to know how to do some things by hand. The calculator can't do it all. So first thing you have to do is know how to set your calculator to a width of 1 period. And then once you do that, you can find all the solutions in that 1 period, usually by doing either second calc intersect or second calc 0. Depends on how the equation is set up. If it's a problem like this, that's going to be an intersect problem. You're going to see where the left and the right are equal. If it's a problem like that, that's not an intersect problem. That's calculating a 0. Where is it equal to 0? So we'll try each technique. Alright, so find all the solutions in 1 period, and then take into account that that answer repeats every cycle. So this second statement is just saying put plus the period times n. Take into account that the answer you found is going to keep repeating at regular intervals over and over. So it's going to look something like that, just like you wrote yesterday. Now, you only have to do these steps if they say find all solutions. If you get a problem, and there's going to be one like this on the test that says, just find the answers between 0 and 2 pi. If that's all it says, you don't have to do that. All you have to do is find all the numbers between 0 and 2 pi and write them all down. We're going to see that sometimes today you're going to have 2 solutions. I think one problem has up to 6 solutions. A problem with 6 solutions would not be one we would do with algebra, because that would be really hard. But with the calculator, it's more repetitive than anything else. Okay, so let's try this one. For today, you don't have to worry about thinking, okay, sine is positive in which quadrant? That's when we're doing it algebraically. Okay, we did that yesterday for simple ones. We're going to focus on graphical. Okay, so we're going to start with put sine in y1. It's already there. And put 0.8 in y2. Now, to find all solutions, before I hit graph, I've got to set the width of my window to the cycle of sine. So what's the period for regular sine?
0 to 2 pi.
Yep, 0 to 2 pi. As long as you set your window so it's 2 pi units wide, that's all you're looking for. Mine already is 0 to 2 pi. Now, just to zoom in a little, I know the highest and lowest that sine goes is 1 and negative 1. So I don't really need to go negative 10 to 10. So let's just go like negative 3 to 3. So here's our graph. Here's 0.8. It's going to be a line up at the top. And how many solutions does it look like we have? 2. So now, if you were finding them by hand, you would be doing something like this. 0.8 inverse sine. That's in degrees. 0.8 inverse sine. It's going to be 0.927. I'll calculate the intersect, but I think it's actually slower to do it that way. Even though that's what we're going to do today, the intersect takes more time. All right, so second calc intersect. I'm going to move my cursor. I'm going to hit enter, 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 and I get exactly the same answer that I just got right here. 0.927. Right, so that's our first answer. And what do I put on the end of that because they want to know all solutions? Plus 2 pi n. If the problem said, find every solution between 0 and 2 pi, that's all I would do. And I'd have one more to find, but I wouldn't put the plus 2 pi n. Only put that if they say all. And now the other one, again, I can probably find the other one quicker in my head than it takes me to do second calc intersect another time. It's just pi minus 0.927. That's it. All right. So if I do it that way, pi minus 0.927, I already have it. Okay. But, yep, and did you do intersect and get 2.21? Yeah, so doing second calc intersect, you get the same thing. Again, we're going to focus on the intersect today. But I'm just showing you they're the same. 2.21 plus 2 pi n. So it's like, if you think of that blue curve, think of it as like a hill, and the red line going through the top of the hill. The first equation gives you the answer that's always on the left side of the hill. The bottom equation gives you the answer that's always on the right side of the hill. Two different answers. Okay, any questions on that one? Now, as I went through it, I kind of showed you how to do it both ways. We're going to get into equations that you're not going to know how to do with algebra. Okay, that one's pretty straightforward. But the ones coming up next, you won't. So you're going to have to rely on second calc intersect. All right, so if you have a function, okay, a trig function, and you set it equal to 0, it's just a reminder that that's called finding the roots of the equation, or finding the zeros. Another name we called it is the x-intercepts. So anytime you're finding where a function equals 0, you're finding where it crosses the x-axis. You're finding the roots. You're finding the zeros. Depending on your calculator, you might see different options. Okay. On the new calculator, if I go to second calc, the option 0 is there. If I use an older calculator, like actually even older than this one, or maybe if you have like a Casio, if you have a different brand, it might say something different. But on this one, if I go second calc, it's a little light. I don't know if you can read it. It says root. Root and 0 mean the same thing. So if you have a different brand calculator, you might see something different. So you know you're finding roots if it's equal to 0. All right, so what we're going to get into is equations like this. If you look at the left-hand side, cosine squared, that's a trig term. Sine, that's another trig term. Each one of these trig functions has its own period. So when you have an equation that has two things in it that each have their own period, how do you find the period of that whole thing? Well, you got to take into account both of them. And I'll show you what you do. So to find the period of a trig equation that has more than one trig term in it, start by finding the period of each trig term, or each periodic term. So find the period of each term that's trig. So if I look at this problem, I'm going to have to find the period of that. I'm going to have to find the period of that. 1 is not a trig term. 1 is just a number. So there's no period for a number. So there's two periods you have to find. Next, once you have all the individual periods, take the least common multiple. And that's the period of the whole thing. So remember, least common multiple is the smallest multiple that two things have in common. So just to give you a simple example, multiples of 3. 3, 6, 9, 12. Okay, so I just listed the first 10 multiples of 3. Now let me list multiples of another number. Let me do 7. 7, 14, 21, 28, 35, keep going. Now if I want to know the LCM, I'm looking for the smallest number that's in both lists. 21. So So 21 is the least common multiple of 3 and 7. If I had something, let's say I did it with pies. 3 pi, 6 pi, 9 pi, 12 pi, 15 pi, 18 pi, 21 pi. And I could keep going. I'm just doing multiples of 3 pi. And now let's do multiples of 7 pi. 7 pi, 14 pi. So if you look at 3 pi and 7 pi, what's the least common multiple there? 21 pi. Yep. So finding the LCM of a number that has pi in it, it's basically the same idea as a number that doesn't have pi. You just find the smallest number they have in common and then put pi on the end, just like the one up above. Okay. So at least now you know, once you have all the periods, what to do with them. Find the LCM. But what if you have something like this? We've never talked about periods for trig functions that have exponents, like squared, cubed. Well, I'm going to give you formulas. It's the same formulas you already know. 2 pi over b and pi over b. I'm just going to tell you you can also use those for this situation as well. And what it basically boils down to is that an even or an odd exponent? It tells you which formula to use. So if you have any of these situations, if you have a sine to an even power, cosine to an even, secant to an even, cosecant to an even, or any tangent or cotangent, even or odd, or tangent or cotangent, we always use the same formula to find the period, and it's pi over b. So we've already been using that formula for other stuff before. I'm just telling you you can use it for even more stuff than you knew you could use it for. Any one of those situations. Now, I put absolute values around the b because if you had something like this, you wouldn't want to let b, you wouldn't want to plug in -3. Because the period is a length. It doesn't make sense to have something that's negative length. So you take whatever the number in front of x is, make it positive if you need to, and then plug it into the formula pi over b. What was the other formula? We had pi over b and 2 pi over b. So you use 2 pi over b for everything that's not mentioned here. Sine to an odd, cosine to an odd, secant to an odd, cosecant to an odd. We already covered everything with tangent and cotangent. Okay. Can I scroll down a little, or are people still copying? So sine to an odd, cosine to an odd, secant to an odd, cosecant to an odd, they all use 2 pi over b. So now you've got formulas to figure out the period of a trig function, no matter what the exponent is, even, odd, and I covered all 6 trig functions you could ever have. Okay, so if you're making a reference sheet for the test, this is probably a handy thing to have, because if you don't get this part, then we're sunk right away because we don't even know what to set the window for. Okay. Got to do this first to get your window. Yep.
Is the whole cosine x raised to an exponent different than just the cosine raised to an exponent?
Well, on paper, it looks like this. That's how we write it on paper. Yeah. But on the calculator, you have to write it like this. Those are the same thing.
The same thing?
Yep.
Okay.
Those are exactly the same thing. This is not. That's totally different. That means take whatever x is, like if x was 2, you'd do 2 to the second power is 4, and take the cosine of 4. Oh. Versus here, you take the cosine of 2, get the answer, and then square whatever that answer is. Okay. Any other questions on this chart? Maybe you can find a shorter way to write all that, but that's basically what it is. Okay, so let's look at our first example. Well, first example with multiple trig functions. All right, we've got cosine to an even power. What's What's the formula you use when it's cosine to an even? Jake? Okay, if I go back, cosine to an even, pi over b. So it's pi over. Now, b is the number that's in front of the letter, inside the trig function. What number is in front of the t? Right here? Well, I don't want to make that look like a 0. What number is in that box? And actually, it's the same number in that box. They're both 1s. So this is just pi over 1, or really just pi. Now, how about the second one? Sine t. There's no exponent. So how do I know if it's even or odd? It's odd. Why? It's always to the 1. Yeah, if you don't see an exponent, it's always to the 1. Sine to an odd, let's take a look. It's down here. Sine to an odd, 2 pi over b. Jaden already told us b is 1 in both cases, so this is 2 pi. Now I have pi and 2 pi, find the least common multiple. What's the least common multiple if you wrote out all the multiples of pi and 2 pi? 2 pi, yeah. Yep. And this situation seems to come up a lot. It doesn't have to every time, but most of the problems that we're practicing, the least common multiple is 2 pi. Now, all that this tells you is how to set your calculator screen. That's all it does. So now, we're going to set our screen for a width of 2 pi. You can do that a lot of ways. You could do 2 pi to 4 pi. Technically, that's 2 pi. You could do 9 pi to 11 pi. But I think the simplest one is 0 to 2 pi. So I would stick with that. Now, to type that in, you can't type it in the way it looks. You have to type it in the way I showed Sam. 2 cosine of x. Very important, the exponent is outside those parentheses. Except they want cosine. Let me fix that. You don't want to have it like, you don't want this. 2 cosine x squared. That's wrong. We're squaring. Putting that exponent on the outside like that means to square the whole thing, not just the x. So this line right here is wrong. All right, so 2 cosine squared x, don't forget the 2, it's under the calculator, plus sine of x, plus 1. And get rid of that 0.8, that's the previous problem. So we're looking for where this equals 0. Basically, that means you're looking for where it crosses the x-axis. We already set our window. Now, if I'm only interested where it crosses the x-axis, technically I don't need to go up any higher. But I want you to kind of see it. I want you to see the top of it. So I'm just going to set my y max to 5. Again, not really necessary, but I have a reason I'm going to show you in a second. Okay, so there's your graph. That's one cycle of the graph. Let's put it here. And let me trace it somewhat carefully. And let me just move it down here. So that's one cycle. If you wanted to see what it would look like with 2 cycles, all you do is you take that, make a copy of it, and if you set your window correctly, the beginning and the end should match up. Perfect. Just like that. So there's 2 cycles of your graph. Okay. And if you did it again, here's a 3rd cycle. So the reason I'm doing that is because if this is my x-axis, you can see that it's going to keep crossing the x-axis forever. One time. I don't have it perfect, but it's one time every cycle. So all you got to do is tell me the first one, and then tell me how often it repeats. Right? So how do I find where that crosses the x-axis? Well, intersect is like if you had a red and a blue graph on the screen at the same time. Yeah. Second calc 0. But yeah, sometimes I try to do intersect because I forget. It's, but it is 0. So pick a point left. Pick a point to the right. Maybe. And do you guess? 4.71. Okay. So that's this answer right here. But once you have this one, the distance between every answer is exactly the same. They're all 2 pi apart. That's why you put plus 2 pi in. So 4.71 plus 2 pi in. You have to write, what was that we saw for t? Okay, you have to write as many answers as you see on the screen. Okay, this one only had 1. Okay, questions on it?
Now, say if it showed 2 periods, how would we write the answer then?
Well, you only want to show 1 period.
Right.
So you force the calculator to only show 1 cycle. If you saw this on the calculator, then you set your window too big. Alright, so you've got to set your window smaller. You'll know if the window's too big because you're going to see a pattern of the same thing happening over and over. You shouldn't see the same thing over and over if you're just looking at 1 cycle. Yep. Alright, let's look at this one. Now, if I want to solve this one, the same way I solved the last one, what do I have to get it equal to first? Yeah, let's get it equal to 0. I think the easiest way is just to subtract something, it doesn't matter which one, and bring it to the other side. How would I get 3 cosine x on the other side? Yep, subtract. Okay, so now we have an equation that has 2 trig terms in it. You've got to find the period of each one and then do the LCM. Okay, tangent x. What's the period of just regular tangent? No exponents, no numbers in front of x, just regular tangent. Okay. Pi over b, and what's b in this case?
1.
It's just a 1. Period's pi. What's the period of, it's just regular cosine. There's a vertical stretch of 3. That doesn't matter. What you want to look for is a number in front of x, and you don't have one.
2 pi.
So the period is just 2 pi, and the LCM?
2 pi.
It's 2 pi. So that tells me 2 things. 1, tells me how to set my window. 2, tells me what to put on the end of each answer, plus 2 pi n. All right, now let's type in, see what we got. Again, both trig functions here, we're kind of lucky. We've got buttons for them. If you don't have a button, you have to deal with that too. Minus 3 cosine x. My window is already 0 to 2 pi. Now, don't worry about really setting your y max and min, because you're graphing tangent. Tangent has vertical asymptotes. You're never going to see the top and the bottom of the graph. Now, when I look at that, how do I know that there's something off the screen I can't see? Well, yeah, there is an asymptote right in here. But if I were to copy and paste this picture over and over next to each other, would it connect right now? No, the left side and the right side don't connect. And I don't know if you can see it, but I can just barely see it. Can you see that very small dot right there?
Are you serious? That doesn't show on the calculator.
Yeah, I did on mine,
Oh,
but...
it's not on mine.
So, I know that there has to be something else off the screen within this cycle, because it has to begin where it ends. So if you set your y max a little lower, you will see that. Let's go like -8 to 8. And now it should end right there, right where I'm circling. Because it has to end where it started. Now, if you copy and paste that screen over and over, the left side would connect to the right side, which is what should always happen. But even if you didn't see that, it wasn't super critical, because all we're looking for is where it crosses the axis, and this part doesn't cross the axis at all, so you can ignore it. All right, so let's do second calc 0. I'm going to do the one in the middle. if someone else can do the one on the left, that would make me happy. Okay, so the second one is 2.13. And it repeats every 2 pi units. So 2.13 plus 2 pi n. I don't know what the other one is yet, but it's also plus 2 pi n. Does anybody have the first one? Looks like it's right around 1, pretty close to 1.
1.01.
1.01. Yep. And there's your 2 answers. Any questions on that one? Alright, let's try this one. 3 sine cubed 2x minus 2 cosine x. It's already equal to 0, so we don't have to worry about that. Sine to an odd power. What's the formula when you have sine to an odd? 2 pi over b. What's b in this case? Yeah, this is the first time we've had a number in front of the x. So this is 2 pi over 2. So what's the period of sine cubed 2x? Pi. So we got that one. And what's the period of cosine? Just regular cosine, no exponents, nothing. 2 pi. And the LCM? It's 2 pi. Again, it comes out to 2 pi a lot. It's not always going to come out to 2 pi. Okay, so now I know what to set my window at, and I know when I find my answers, I need to put plus 2 pi in. All right, let's graph it and see what we get. So 3 sine cubed 2x. Right, so the way you want to type it in is 3 sine of 2x, close the parenthesis, cubed, minus 2 cosine x. My window is already 0 to 2 pi. It's been 0 to 2 pi for every problem we've done today. So I'm just going to hit graph. And we're looking for where it crosses the x-axis. Let's make it a little bigger. And how many times does it look like it?
6.
Yeah. 1, 2, 3, 4, 5, 6 times. And it begins exactly where it ends, which means you've got a good window. So we have to do second calc intersect on all 6. Now, I already did it, so I already know the answers. But is there any question on how to do second calc 0? I think I said intersect and then 0. So everyone's okay if I just write the answers then?
Yeah.
All right, so the answers are 0.50. That's the first one. The second one is 1.25. The third one, 1.57. The fourth one, 1.89. The fifth one, 2.65. You can check them, that's what they come out to. And 4.71. And every one of them is plus 2 pi n. Now, on a test, I'm probably not going to give you one where you have to solve 6 times, maybe 3 or 4. But if you can do something 3 or 4 times, I'm sure you can do it 6 or 7 times. Just the same calculation over and over. What letter was that? X equals. You don't have to show it like this. X equals. Okay, so there's all 6 answers. Okay, questions on them? All right, so every problem we've done right now, that was an equation. This one had an equal sign in it. That's an equation. First one we did, equal sign. That's an equation. Well, last thing we're going to look at is an inequality. If you can solve an equation, solving an inequality, same thing. The only difference when you solve an inequality is the answer is usually an interval. It's not like x equals 0.6. It's usually an interval. X is all the answers from 0.75 to 1.4, right? It's an interval. It could be a closed interval or open, so you might need brackets or parentheses, but it's an interval. And you do it the same way. If you can find the interval that's a solution in the first cycle, that interval is going to repeat every single cycle, just like an answer. Okay. Also, keep in mind vertical asymptotes, because if you have a vertical asymptote in a problem, you can never include the number at an asymptote. So if you have an interval and one end of the interval is an asymptote, it's always a parenthesis. You can never include vertical asymptotes. And vertical asymptotes can be a little tricky to find with tangent, especially with tangent and cotangent. But if you have a vertical asymptote in a problem, it's going to be very easy to find. It's going to be something you can look at the calculator and tell what it is. Because the calculator doesn't have a feature that says find asymptotes. It can't find them for you, but you'll be able to tell. Let's try a couple inequalities. Right, so this one is sine of x is less than cotangent of x. Now I want to solve it the same way we've done the past couple. I want to get 0 on one side. So how could I do that? Okay.
Subtract cotangent.
Sure, just subtract cotangent. So what I'm now looking for is where my graph is less than 0. Where is this graph under the x-axis? Okay. Let's set our window. What's the period for sine? 2 pi. What's the period for cotangent? Pi. And we've done this enough at this point. There's your LCM. Okay, let's graph it. So I've got sine x. How do I type cotangent in? 1 divided by tangent. Yep. And my window is already 0 to 2 pi, so let's see what it looks like. Okay, I see 2 sections where it's under the x-axis. And I'll trace it in red so you can see it. From here up to, now can I include the x-axis or do I have to be less than the x-axis? I have to be less than. So it's like I'm going to put an open circle. And then from here up to right there. I have to write those 2 things in red as intervals. Okay, let's start with the one on the left. That curve in red, how far left does it go?
1. Less than 1.
Yeah, well, it goes even less than 1. What does it get close to?
0.
Does it ever reach 0?
No.
No, it's because there's an asymptote right there. So you cannot include 0. But it gets as close to 0 without touching it as you want, up to the open circle. That's where the interval stops. So how do I get that? Second calc 0. If somebody can find the other 0, we're going to need it in a little bit. So it's up to 0.905, not including it, because that doesn't have an equal to under it. That's the answer to my first one. Or, now I need to write my second one. Now, it looks like there's another asymptote right there. My window is 0 to 2 pi. Where does this asymptote look like it is in the window? It's pi. pi, it's right in the middle. So I told you if there was an asymptote, you'd be able to find it easily. You can always check that it's pi by plugging pi in, and you get an error. So the second interval starts at pi. Can I include pi? No, it's an asymptote. You could put pi or you could put 3.14. We did decimals for everything else, so might as well keep doing decimals. And now what about where it ends? Can I include that? No, because it has to be less than 0. If that was an equal to, then I could put a bracket like that, but it's not. 5.38. Thank you. Now, how often do those two intervals repeat? Every 2 pi, just like an answer. So you're going to just put plus 2 pi n. So in other words, if you added 6.28 to every one of those numbers, you'd get those intervals in the next cycle. And if you added another 6.28, you'd get them again in the next cycle after that. That's an inequality. Questions on that? All right. Let's graph this one, and let's just leave it as is. So don't get it equal to 0. Let's just type it in right away and see what it looks like. Sine 2x and x squared minus 1. Remember, x squared, that's a quadratic, that's a parabola. So I'm looking for where the sine function is above a parabola that's been shifted down 1 unit. Okay. So where is the sine function? Where is the graph in blue above the graph in red? So there's the graph in blue, there's the graph in red. Is that a good graph of the parabola? No, not really. I'm only seeing half of it. I think the graph in blue is above the parabola more off the screen. So let's set a window of like -5 to 5 so we can see the whole parabola. Well, as much of it as we need to see. So where is the graph in blue above the graph in red? On that part that I just traced in black. Now, can I include where they cross? Or should I not include it? I should include it. It says less than, it's greater than or equal. So it would be from here to here. Now, is that interval going to repeat again off the screen? No, because you're comparing a periodic function to a function that's not periodic. It's not like that red parabola is going to look like this. It doesn't keep repeating itself. When you draw a parabola, you get one parabola and that's it. So the only place that the parabola is above the blue curve is right here. Other than that, the sides of the parabola just keep going up higher and higher. They're never coming back down. Okay. So at this point now, it's just calculating a couple intersects. So -0.47. I put a bracket because it's equal to?
1.26.
You already got it? 1.26. Thank you. Don't put plus 2 pi or anything, because that interval doesn't repeat again off the screen. The red parabola doesn't repeat off the screen. Okay. Questions on that one? All right. And last one. So the last one is a double inequality. So what that means on the calculator is you're going to type in 3 things. And we're usually looking for where something is sandwiched between 2 things. Color makes it a little easier to see. You don't need color to do it. But it just makes it easier to look at. So with a double inequality, you're going to have 3 parts. Left, middle, and right. Put one of them in y1, one of them in y2, one of them in y3. And then interpret the picture. All right, so let's put in negative x, x sine x, probably a good idea to clear out first. X sine x and x. And what I'm going to do is underline these in color, which one is which. Negative x on mine is blue. X sine x is red. And in black is x. Okay, I'm going to start with zoom 7, okay, and see what it looks like. Zoom 7 is just a preset zoom for trigonometry functions. Zoom trig. So there's one of my lines. There's that x sine x, but it's kind of going off the screen a lot. I can't really see it that well. So what I want to do is zoom out. So if you press zoom and then go to 3, it'll zoom out so you can get a better look at it. It's like you're stepping back so you can see. You're zoomed in too close. So zoom 3, hit enter, and now I think you'll be able to see it better. Okay, so we're looking for where a graph is sandwiched between two other things. So let's look at this. We're looking for where the graph in red is above the one in blue, but below the one in black. From 0 to infinity, right? If you start at 0 and you head to the right, the graph in red is above the blue, but it's below the black. Now, can I equal 0, or should I put a parenthesis? I can equal it. It's okay for it to equal. How about infinity? You can't equal infinity. So if you look at any x value from 0 and up, it'll fit that condition. And let's look at the last one. So the last one is where color comes in handy, because if you did this in black and white, I'm going to ask you how the graph I'm about to do would compare to the one that I just had if it was black and white. Okay. Let's graph this one. So absolute value is under math, number, absolute value. Okay. And do it again. Math, number, absolute value. So the coloring is the same. The negative absolute value is in blue. X sine x is in red. Bless you. And the one on the right is in black. Keep the same window. Now hit graph. Now, if you look at those two graphs in black and white, what would be the difference?
You wouldn't be able to tell the difference if it was just a black and white photo.
You wouldn't be able to see any difference at all. But there is a difference. It's kind of an important difference, yeah?
So the blue line is, it goes up and down, I don't know how to say it, rather than going straight through it.
Yeah. In the one on the right, there really is no diagonal lines, like the one on the left. It just looks like there's diagonal lines because you have two V shapes back to back. So it kind of looks like it's a line, but it's not. It's just two V shapes. So now let's see what the question was. Where is the graph in red above the blue, but below the black? All the time. It's always above the blue, and it's always below the black. So how would you write your interval? Yep. And that's how you solve a double inequality. Right, so I think yesterday and today are kind of related because we're still solving trig equations. Tomorrow is like its own separate thing. That's why we're going to have a review day on Thursday. Okay, so pretty much every problem tonight you do need a graphing calculator. So it's page 401. It's 5, 7, 12 to 15. 19 to 23, just the odds. 29, 31. And 33 to 37, just the odds. So we'll look at that tomorrow. We should be able to finish everything up for the week tomorrow as well. And then review day Thursday and test on Friday.